lots of different and really good talks in the passwords track. I have to say that this is the 10th time I do the passwords track or PasswordsCon. This is my 4th year doing it in Las Vegas. It's the 3rd year I do it in cooperation with B-Sides. And the next PasswordsCon is going to be at the University of Bochum in Germany in December for 2.5 days. And then it's a complete conference, so there's absolutely nothing else but password-related talks for 2.5 days. And there's a really good brewery just next to the university as well, where we are going for an engineering excursion in the evening, as we say. So I'm not going to, use too much time up here. Our first speaker is Jim Fenton. For those of you who have heard him before, he's a really good speaker. I really like the stuff he's bringing to us. And today, a very interesting talk toward better password requirements. So, Jim, I will just hand it over to you, and we'll get started.
Thank you. I think we're a couple minutes early, but that's all right.
Hold on video as well.
I'll start a little bit slowly. I'm Jim Fenton. Good morning, everybody. Thank you for coming. We've talked in PasswordsCon and in a lot of other venues about a lot of the ridiculous things that we're putting people through in creating passwords. Composition rules, expiration, as Lori Craner just spoke, for those of you that were in the keynotes. And it isn't very often that we have an opportunity to create a set of password requirements or to kind of go through and rethink based on the research that's happened and so forth about what password requirements really should be. And so this talk is an attempt to describe an effort that's going on to do that, going on at the National Institute of Standards and Technology, NIST. But let me start with a little bit of a disclaimer. We always have to start with a little bit of legalese or something like that. I'm a consultant for NIST working on the revision of SP Special Publication 800-63. I don't speak for NIST. I'm not a NIST employee. So please bear that in mind. Even when I use the pronoun we, I really kind of feel like a member of the team, and I have a tendency to refer to NIST as a we, even though I'm not really a NIST person. But bear that in mind. And then the other thing is that what I'm discussing is what we call a preview draft, and I'll get into what that means some more. Everything is very fluid at this point. There are obviously there's been a starting point. There's been a lot of internal thought and discussion about what that starting point should be. That's reflected in the preview draft that's up and posted right now. But these things can and will change, and sometimes they can and will change on a daily basis. So let me give you a little bit of context about where it is that we're talking about creating a new set of requirements. Special Publication 800-63, which in the past has been called Electronic Authentication Guideline for various reasons, we're calling it Digital Authentication Guideline now, is a response to another document that was created in 2004 by the Office of Management and Budget in the White House. And that document, which is called MO404, it defines a set of 4 levels of assurance that and how to decide what level of assurance a particular government application is based on what the risks are, and whether maybe there's a threat of life, or whether somebody's privacy might be breached, or any number of other things. And so it provides a basis for categorizing federal applications into these 4 different levels of assurance. And then 800-63 was created in order to respond to that and say, okay, here are the things that you need to do with identity proofing, with authentication, and with assertions in order to respond to each of those 4 categories of applications. The publication, as I've been saying, is primarily oriented at federal government agencies, although a lot of other people have adopted it for other applications as well. There's a major rethinking and rewrite of 800-63 that's going on. And a lot of that has to do with an executive order that came out about 1.5 years ago, which mandates the use of what they call an effective identity proofing process and multiple factors of authentication for a lot more applications. In particular, anything that citizens, consumers might log into and obtain personal information. So thinking of Social Security, IRS, Veterans Administration, those sorts of things that people log into that they might obtain personal information about themselves from are going to require 2-factor authentication. Here's the first use of we. NIST has broken this into 4 documents. There's a sort of a top-level document, which is 800-63-3, 3 being the revision number. And then there are now 3 sub-documents that are new. 63A, which deals with identity proofing, which is the process of associating a particular real-world person with an online account. How do you make sure that this person corresponds with that account? 63B, which deals with the authentication process itself, and that's where I'm going to be focusing most of this talk. And then 63C, that deals with assertions that would be used in a federated identity system, where the verifier of the identity is not the same as the party that you're actually logging into. Now, one of the things that this update has is a few guiding principles, and these aren't written in stone anywhere, these are just some that I jotted down. But these are characteristics that I think have been informing the process of this revision. We really want to do something better in terms of user experience. We've talked in the past at PasswordsCon about all of the things that users might be required to do, and they always find a way to cheat. And so if you make it too difficult for users, they're going to find a way around it and not achieve the level of security that you want anyway. We want to have realistic security expectations. As I mentioned earlier, 2-factor authentication is going to be required for more things. So a password as a single factor we're recognizing has a useful but not an ultimate level of security. We're not trying to lean on the password too hard. So we therefore don't want to put users through a difficult process in order to try and achieve something that we're not achieving anyway. We want to try and put more burden on relying parties, websites, verifiers, as they're referred to do the right thing in terms of the way they store credentials, the way, the kinds of credentials that they accept, rather than to put more burden on the user. And we also don't want to ask, and this kind of repeats what it said earlier, we don't want to ask users to do things that are really just not helping. So some of you may not have worked in the standards world before, but we have different levels, different terms that we use that are levels of requirement. So the highest level and I'm referring to now the NIST usage of these terms, and I'll kind of compare them with IETF that I'm also familiar with. The highest level is shall, which means that it's an absolute requirement. IETF tends to use the term must instead. They're more or less equivalent. There's should, which in the NIST formulation is as it describes there. IETF's is maybe a little bit stronger. It's that there may be good reasons to ignore this, but you should really understand the implications and, in other words, have a good reason if you're not doing a should. NIST is maybe a little bit, not quite that strong of a statement. May, of course, just means it's something that's permissible, and although IETF actually puts in some being concerned with interoperability a lot, IETF also puts something in there that if something is a may, that you also have to consider the interoperability consequences of that. So this being PasswordsCon, I'm going to focus on what the document calls memorized secrets, which we commonly call passwords, but also passphrases and pins. I tend to use memorized secrets in order to be inclusive of all of those things, unless I mean a particular one of them. Like particularly, we distinguish pins in some cases from others. So here's a quick summary of some of the things that are changed different in the new draft, as it stands right now, of course. Memorized secrets need to be at least 8 characters in length, and that the relying party should accept long memorized secrets of up to 64 characters, and I'll talk about the rationale for that in a minute. We're using a dictionary in order to disallow common passwords, and we want to be very liberal with the character set and what people are allowed to create their passwords from. We don't want to impose a lot of mental burden on trying to say, well, gee, no, that particular character I'm not allowed to use here. We're discouraging the use of composition rules, hints for passwords. Knowledge-based authentication is gone, and routine password expiration is also discouraged. So let me go into a little bit more detail about those. So in terms of the minimum length, there are really 2 different requirements that you could try to meet for minimum length. One is to defend against online attacks, and the second is to defend against offline attacks as well. Online attacks, you have the advantage that you can limit the number of guesses, or limit the rate at which guesses of the password come in. So it's an easier requirement to meet. Offline attacks, of course, you're dealing with potentially the compromise of the credentials, and you're expecting that people are going to create something that's really very difficult to brute force. It's extremely hard to do that. And we've talked about this a lot in past PasswordsCons. And so we're really focusing on defending against the online attacks here. We've had a few comments saying, gosh, that's an awfully weak requirement, only 8 characters, shouldn't it be more than that? And there's maybe some discussion about whether it should be 10 instead of 8 or something like that. Making it dramatically more simply drives up the mental burden for people who are trying to use these systems, and we don't think that we're going to get to the point of being able to adequately defend using length against offline attacks in any case. The other thing that we're doing here, and this is kind of a general comment about the specification, is to be trying to be consistent about the requirements at different security levels. So at different security levels, what we call authenticator assurance levels, AALs, the requirements for a memorized secret are all the same. As you go to a higher level of security, though, If you go from AAL1 to AAL2, it becomes a two-factor authentication, and an AAL2 to AAL3 requires a hardware factor as well. Requires that one of the factors be hardware. So we're trying to be consistent about that, and the old limitation of 6 characters at LOA 1 was thought to be a little bit too weak. So maximum length. The specification didn't talk about maximums at all before. And we've seen all sorts of situations where you're required to have at least 8 characters or at least 6 characters and a fairly narrow range of length. There isn't any reason in terms of storage or anything else why the length can't be fairly liberal. We want people to generate something that is memorable to them, and we want to constrain that as little as possible. So the specification says that the verifiers shall accept memorized secrets up to 64 characters in length. They can do longer than that if they want. And 64 characters is kind of fits on a lot of screens. It's not an overly long thing. Per?
Question about that one. Do you have any research done to say that it fits on many screens?
Per was asking if we have any research that it fits on many a
survey, something?
No, we haven't. There hasn't been any particular investigation that was a little bit of a kind of let's put in a number and see what people say about it. So that's if people feel that that's inappropriately large. I wanted.
Anybody into design or usability studies here? There's a job for you.
The standard terminal is 80 characters wide, right?
Yeah, I pointed out that the standard terminal is 80 characters wide, and I think that's somewhat the rationale, although it's a kind of an old-fashioned rationale.
We're not displaying passwords anyway. We're not echoing them.
It mentioned that we're not displaying passwords anyway, but stand by. I'm sorry?
Portable devices aren't 80 characters.
It's true. Portable devices are not 80 characters. So there may be some question about this on mobile devices. But the point is, let's not make it an 8-character minimum and a 10-character maximum or something silly like that.
Microsoft is 15.
I won't comment on Microsoft being 15. But the point is, when you're storing the password, you're going to store the hashed value anyway. It's a constant length. So it is really not a burden to try and accept a somewhat longer password than it is to just accept a 10 or 15 character password. Now, somebody has pointed out that if we were to allow like multi-thousand character memorized secrets here, there might be some potential of a DOS attack against the verifier through the multiple rounds of hashing that you're doing. And so fair enough on that. Maybe you don't want to go too crazy and allow people to use War and Peace as their memorized secret. But a length of on this order should not be burdensome for the verifier. Now, we were talking about usability. I think Per was asking if there were usability people in the audience here. We have some really good usability people. There's that we again. NIST has some really good usability people that they have assigned to this project. And one of the things that was kind of surprising to me was the comment that they made about space characters. They were concerned that people would either forget to put in spaces when they're typing their password, not remember whether or not they'd put spaces in when they created it, or maybe there would be things like they'd type 2 spaces and it would be kind of an invisible failure. So the thought here is that we definitely want users to be able to type spaces in their memorized secrets. It's a natural thing to do. But they don't really add that much extra entropy or randomness, whether they're there or not. So we allow for the possibility of canonicalizing them out, essentially stripping the space characters and then hash and store that value. And it provides, yes, it provides a little bit of wiggle room when if an attacker were to get a hold of the password and all of that. But really, if they had enough information to get the memorized secret anyway, it really wouldn't add that much extra difficulty for an attacker to figure out where the spaces ought to be. Okay, character set. The previous version of the specification said that the alphabet had to be of 90 or more characters, and this was largely from the standpoint of trying to estimate the possible entropy, and that was that whole process was a little bit fraught. The new specification is saying that the verifier shall accept all printable ASCII characters. Now, we see all sorts of exceptions to that now, where they won't accept double quotes or won't accept certain other characters. And you look at some of these requirements and you say, oh gosh, it looks like they're trying to predict against SQL injection attacks or something of that sort. That shouldn't be a problem. Before it goes anywhere near a database, the memorized secret needs to be hashed. And so the hash isn't going to contain those values, so why do we need to constrain people from using all of these things? We want to make it as easy for the user as possible. We're not trying to turn this into a contest here. We're also saying that it should accept Unicode characters. And yeah, some people like to put emoji characters in their passwords, and that's fine, I guess. But I think it's also very important from the standpoint of international users, even for the federal government, there's an awful lot of consumers that English is not their first language, and something memorable might not be expressed in the English character set. So we're trying to get away from all of these usability problems, and hopefully this will help. Hints and prompts. We see sites that, in fact, I just ran into this when I was setting up Windows 10 the other day, where it says, you need to provide a password hint. And we really think that it's training people not to treat this seriously. You get password hints that are of the form, my password is blah, and obviously that's not helpful. So, and I've even seen attempts to try and make sure that the password hint doesn't contain the password, and it gets to be kind of a point counterpoint sort of thing. So we're just saying shall not permit the user to store a hint, and shall not prompt the user with particular types of information that should be used as their password. And we'll get to knowledge-based authentication in a minute. Just because that weakens everything. Throttling is a tricky business. We want to throttle in order to protect against online attacks, but if you throttle too much, you're going to essentially either make it hard for the user or create the possibility of a denial of service attack against a particular user. If somebody wants to harass somebody, they could potentially make it so that they can't log into their account somewhere. So we've not, the previous revision of 800-63 had some guidance in there about things that could be done in terms of using CAPTCHAs, whitelists, and various things that could be used to try and mitigate the possibility of an attacker coming along and trying to lock somebody out of their account. Those are largely unchanged, but we've still gotten some comments about things like, well, gee, you should make the failure count based on IP address or something like that. Well, the problem here is that if you do some of those things, you got to remember what the capabilities are that the attackers have. Attackers typically, or quite a few of them, have access to lots of IP addresses. Maybe they have a botnet at their disposal that they can use for proxying and so forth. So we don't want to weaken the whole throttling business by making it possible for an attacker to game the system, as it were, especially when using the IP address is probably still going to have the same impact on a user that doesn't legitimately remember their memorized secret. And by the way, we're using this throttling in some other places in the specification as well. Some places, like when you have a one-time password, from a key fob or something like that, and it might have a 6-digit number. That's roughly 20 bits of entropy, I guess. And in cases like that, where the entropy of the verifier, of the authenticator output, as it's called, is relatively small, throttling is also required there. We've all run into composition rules, and we've talked about them a lot at PasswordsCon in the past. Of course, these are the rules that say you need to have different classes of character, uppercase, lowercase digits, but there are a lot of other more complicated things that people are asked to do. Don't have more than 3 consecutive characters that are the same, or it gets to be a real mental exercise to try and come up with a password or a memorized secret that satisfies all of these rules, and they're different in different situations. You have to sit there and study them for a while sometimes. And they don't do that much good, research has found. So the new, the draft now says that the verifiers should not impose composition rules, but should instead use a dictionary, a blacklist, if you will, of disallowed memorized secrets. It doesn't say a whole lot about how to create that dictionary. I think that's something that might be a little bit too. I'm not sure that we have enough information about exactly how that ought to be done, and that might be done in different ways in different situations. But we'll talk a lot more about dictionaries here. But I mean, the rationale, of course, is that composition rules are just really hard on users. Fair.
Simple one on that one is, I think it's kind of cool the thing that Facebook does, because they actually allow you to use the opposite case version of your password to log in. So if your password is capital P and lowercase assword, you are actually also allowed to log in with lowercase p and uppercase assword. They do that.
Okay.
And that's simply because when you have 1.4 billion users, quite a few people actually have caps lock turned on, and they were not supposed to. So that's the thing that Facebook, I think they came with that like maybe 2 years ago or something, 2 or 3 years ago.
Okay. Para notes that Facebook has some ability for users to enter passwords in the opposite capitalization. Yep. I guess that would come less as a composition rule, but maybe as another form of canonicalization.
Yeah, I mean, you could say it's an improvement of the UX on the service provider side. So they just take into account that people may have pressed caps lock, and so they accept it.
Yeah.
So Facebook then stores your password in 2 different formats.
No, it doesn't.
They don't?
They just try again.
Yeah,
If it
that-
fails, they just run through.
Oh,
again.
that's the way to do it, okay. Yeah.
right, right. So if it fails, it just tries again.
Won't you end up in a situation if you have too many known secrets that the user will end up having to enter many times because the dictionary is so well known of positive known secrets?
The question is, won't we have a situation where there are too many known secrets and users have problems with that? Stay tuned. That's the next couple of slides. Up and back, I see a hand.
Corollary to that question, if I want to deliberately use an insecure password, why can't I?
The question is, if I want to deliberately use an insecure password, why can't I? Part of the issue here is that the user, in many of these cases, the user is not the only one that has a stake in the privacy, in the security of the account. In a healthcare situation or something, a lot of other sensitive situations, if there's a breach, it's a significant burden on the party that you're logging into as well in order to disclose and mitigate that breach. So there are.
The reason I ask the question is that it's not communicated to most users at companies. It's never explained why the burden is on the users to comply.
That at companies it's never explained to users why they have this burden. I agree. There needs to be some better training there. We're doing our best to make the burden on users to mitigate the burden on users, but we can't make it go away entirely. All right, so let's talk a little bit more about dictionaries. I mean, one of the questions that you might ask about dictionaries is sort of how big should it be? If it's too small, if the dictionary has 10 entries in it, then there are an awful lot of frequently guessed passwords that are still allowed. If the password is enormous, then you're basically making it very hard for people to come up with something that isn't on the list. So that's one question. A second question, and I was talking with Lori Craner about this a little bit earlier. What happens when we use just a dictionary like this? Will users do something predictable when they're told that, I'm sorry, that's not an acceptable password? So will they do something like put a 1 on the end, put an exclamation point on the end, just something very minimal in order to try and get around the dictionary? That's a subject for a little bit of research, and I understand that's going on. And if we do have that possibility, of course, the dictionary becomes a great resource for somebody that wants to do some offline cracking. It's like, here's the starting point. Now just apply the following however many transformations to the entries in this dictionary. Maybe change all of the L's to 1s or whatever. You could do the leet speak sort of transformations. You guys have all thought about a lot more of these than I have. But you don't want the dictionary to be necessarily something that is going to help the attacker attack memorized secrets, and that's a concern. So I decided to play around with dictionaries a little bit. How big of a dictionary is effective, and what's in it? So I started. Mark Burnett has curated a list of 10 million compromised passwords, and that I thought that was a good, kind of publicly available starting point. So I took that list, limited it to the entries that are 8 characters or more, and got about 500,000 entries and about 3.2 million distinct passwords. And here's kind of what they look like. And this is a distribution that you'd kind of expect. This is, of course, log distribution vertically, but you can kind of see down just kind of a sampling of the things. Of course, password is the #1 password, but we've got some interesting good ones. Mot de passe, which is the French one, and this, the welcome 123, and then you get down here and they get a little bit PC7FDDMH. That's a little bit more obscure. So it kind of has the right form. This was a pretty useful list. There are an awful lot of passwords that are of the form of a date, which is maybe more than we expected there, but you're probably not going to get any sort of a list that's absolutely pristine. One other thing you can do is you can do the log-log graph, which ideally for a Pareto distribution like this should be a straight line. It's got a few bumps, but it's got about the right kind of distribution. So kind of think that we're doing roughly the right thing. And so on this graph, if you've, for example, more than 3 occurrences of a particular password in the list, there are about 100,000 entries. So you probably don't want to disallow every password that has ever been used in your corpus. You just want to disallow the ones that are commonly used. So the point here is that we start with a corpus of several million, and we get down to a fairly manageable number fairly quickly just by disallowing the passwords that are there 1, 2, or 3 times. And that doesn't necessarily need to be the way that it's created, but it's just kind of an existence proof, I think, really. So it was pretty simple for me to build what seems like a reasonable dictionary. Of course, I don't have any real testing to indicate its effectiveness. But we still have this problem. If bad password is on the list, will users try and change their password, try and use bad password 1 instead? And that would be a serious shortcoming of this whole thing. And hopefully we'll find out from some research about that fairly soon. Now, I talked earlier about trying to put a little bit more of the burden on the verifiers on the non-human side of this. And the previous versions of SP 800-63 had some guidance there. It fortunately said, shall not store plain text, but of course that's not very much of a requirement. It could be just hashed once or not even salted, anything like that. And of course that was at LOA 1, which we discussed earlier was a little bit weak. At LOA 2 and higher, it says that you may salt and derive the key or encrypt, which again, it's a may. It's not a very strong requirement of the specification. So this was something that needed to be strengthened, and so the draft now says that the memorized secrets shall be hashed with a 32-bit random salt using an approved key derivation function. Of course, the requirement for using approved functions is kind of throughout the specification. There are some popular things like bcrypt that are not currently approved functions, but if you're not a federal agency, you perhaps don't need to deal with the approved aspect of it as much. We say that it should be done 10,000 iteration rounds. This is, of course, to drive up the work function for attackers. And we also say that it should use a keyed hash, like HMAC, with a key stored separately. Because, and this is really important, if you use a keyed hash and the key is not breached, then there is really no offline attack possible, and that's the best of all worlds. Now, you don't want to put all of your eggs in one basket or all of your eggs in one key not being breached. So actually it might be a good idea to do both of those things. but we really want to encourage or require verifiers to do a better job of storing the values that they use to verify memorized secrets. And now we get to the point of talking about displaying secrets, and this came up earlier. This was some more input from the user experience team at NIST, which basically said that, you know, in an awful lot of situations, people are trying to type, and we're trying to encourage people to use longer memorized secrets. And they're trying to type memorized secrets in a situation that there isn't anybody else around. They're sitting in their office at home or something like that. Why not give them the option? Why, you know, there are sites that do this now. Why not give users the option of checking a box and making the what they're entering visible? And you know, of course, you don't want to do that in all situations. You really do want to obscure it in situations when people are likely to be shoulder served. But this is something that I think will encourage people or make people more confident in creating longer and therefore more secure memorized secrets. And it just kind of takes the burden off. Expiration, Lori Craner in her keynote talked a lot about the expiration of passwords. There was the specification before was silent about this. It's now saying that verifiers should not, it's not an absolute requirement, but it's a should not require memorized secrets to be changed periodically or otherwise arbitrarily. Of course, if there's a breach or something like that, you should absolutely require users to change the passwords. But just doing it for the sake of doing it is thought to cause, if not negligible benefit, perhaps even more harm than good. Now I'm going to broaden out a little bit and talk about a few other types of authenticators besides passwords, because there's a lot more to the specification. I've been talking about a very narrow piece of it. Previous versions of the specification had a thing called pre-registered knowledge tokens. Token and authenticator are synonymous. We're using authenticator now in order to avoid other conflicting uses of the word token, like in OAuth tokens and things like that. That has been eliminated in the new specification. There is no longer a pre-registered knowledge token, and I think we all know why. It's because they're subject to reuse and they're not very strong in the first place. So questions like your first pet are no longer allowed. There's been a lot of talk in the last week or two about out-of-band authenticators, and I'll get to the question of SMS in a minute here. But the point of an out-of-band authenticator is that it should be uniquely addressable and separate in some way. Of course, virtualization makes the question of separate a little bit vaguer, but the communication channel that it communicates over should be separate from what you're authenticating on. There are some new possibilities here to where the response can actually pass over a protected channel. It can be kind of more of a one-way in the opposite direction from what you might think of, say, with SMS. Part of the idea here is, since we're requiring that it be a uniquely addressable device, there's a requirement now that the device authenticate itself using approved cryptography in order to establish that it's a unique device and a particular device, because this is out-of-band authenticators are something that you have, not something like a password. So we're trying to prove the possession of a particular thing. SMS, there have been some pretty high-profile breaches. I believe Lori Craner actually had one as well. And Ladar Levison, who's known for the LavaBit email service, and DeRay McKesson of Black Lives Matter, all suffered breaches that were contributed to by compromises in SMS-based two-factor authentication. And who knows how many more there are that we don't hear about. But the point here is that there's both kind of the physical security of the device and the whether or not the SS7 network could be compromised. I don't actually know of any SS7 based attacks on SMS two-factor. But there's also a very substantial ecosystem around mobile phones, where every outlet that can sell you a phone basically is empowered to help get your current phone number assigned to that phone. And we're depending on the reliability of thousands and thousands of retail clerks in random stores all over the place in order to make sure that someone's telephone number isn't assigned to an attacker's telephone. That, I think, is the biggest weakness in this whole system. It isn't so much of a technical weakness as a social engineering weakness. And I think that's what's happened with a lot of the SMS attacks that we've heard about. There's also the possibility that a voice over IP phone number can be used. And of course, if you're using a VoIP phone number, it isn't proving the possession of a device at all. And that's why it says shall not be a VoIP number. That's just not proving possession. There are a number of changes. I could probably give a whole hour-long talk about biometrics. So I'll just kind of touch on it briefly. The requirements actually haven't changed that substantially in terms of how they can be used. A lot of people were concerned about the fact that there were fairly limited uses for acceptable uses for biometrics in the previous versions of the specification. But they still need to be bound tightly to a specific device that's doing the authentication. You can't have the situation where you have maybe a retail store that you use your thumbprint at any cash register or something like that. You need to really enroll the biometric with a particular verifier. And therefore, every time you're using a biometric, it sort of becomes a multi-factor authenticator, because you're proving not only the biometric, but you're also proving the possession of the device. So that's kind of where biometrics are special. They're always multi-factor in the accepted uses here. There are now performance metrics that are required for biometrics in terms of the false match rate and the false non-match rate. I won't go into the specifics, but they actually aren't as strong as I expected that they would be, based on apparently what's being achieved. And there's a hard limit now on consecutive failed attempts. Very much like if you're using biometrics, if you're using fingerprint on your iPhone, after a certain number of tries, it'll say, "No, enter your PIN." That's kind of what's required here, and it has to do with what those performance metrics actually are that can be achieved. So you still need to have some sort of a backup for it, maybe a memorized secret to use if you hit that hard limit of 10 failures. One thing that has been liberalized is that verification can be performed centrally, providing you're still binding it to a particular device and meeting all of the other requirements. So I'm going to talk briefly about how everybody can participate in this process. We're doing something very different this time from the normal special publication update process. There's a preview draft that's available right now. You can look at this URL. And if you can't remember it all, just remember pages.nist.gov, and it gives you a directory, and you'll see 800-63-3 at the top. But it's live off of GitHub. So as changes get cranked in and so forth, this document changes sometimes several times a day. So have a look at it. Please do submit comments. There's some guidelines on how to do that. You submit the comments right now via issues on GitHub. Some people have actually submitted pull requests, and you can do that if you want. But issues are fine. And the idea is that we're doing a very open and a very continuous integration sort of revision of this document, and thus far it's been working out very, very well. The public preview period runs until the middle of September or so, and then after that there will be the standard formal comment period, because not everybody's comfortable with this model with GitHub and all of that. But we're really hoping to get as many comments as early as possible, and have that formal comment period perhaps be a little bit shorter than it might otherwise be. So that's about it. If there are any other questions, I'll try and handle those in the time remaining. Yes, sir.
Hi, thanks. I appreciate how open you guys are being with this. I have two short related concerns. One is perfect is the enemy of good enough, so I worry that you might be raising the bar a little high for some cases. And the reason that worries me is your answer might be this is just for federal agencies, and then that's not true anymore, because SP 800-171's already hit us, or is about to hit many of us. And so we're already now being told FIPS validated cryptography for confidentiality. This could be the next thing that becomes mandated upon the general industry. So it's not just for federal agencies. And that's fearful if the bar is raised too high.
We're mindful of the fact that SP 800-63 is used quite a bit outside of the federal government. At the same time, there are some significant concerns with things like storage of credentials and the places where two-factor authentication is required, where things either just really do need to be improved, or there are actually mandates, like in the executive order that came out, saying that we need to do two-factor authentication in a lot more cases, and so we really need to figure out how to do that more at scale. And but thank you. Yes.
One simple question. So it seems the majority of the spec is being guided from the perspective of the user and user experience. Are there guidelines on foiling common malware strategies like keyloggers and other attempts to circumvent or capture that user data? Such as if you're displaying the password and there is a screen capture tool on that device, what would you do?
So that's a good question about a screen capture. I'm personally been thinking about the question of malware or man-in-the-browser, man-in-the-middle attacks quite a bit. Of course, yeah, there is. I guess there is a new risk of displaying the password if a screen logger is there, but I don't see that as being any more likely or likely to be there at times when there isn't also a keylogger. So I don't see that as being a significant new and additional weakness that's introducing.
Okay, last one before we do a short break.
So I had a couple quick questions. So when you mentioned the out-of-band process with SMS. So I think what I heard from you is the basic reason that that is being cut off is because it cannot authenticate the device. Is that correct?
That's right, because what out of band is trying to do is trying to establish possession of a particular thing.
Okay. And then, real quick, the requirements for authenticating the out-of-band provider or even other non-human based devices, is there any call out in the section or in the specification about, or the standard about that? So I'm thinking like app passwords, and even you mentioned that the out-of-band provider has to authenticate. Are there special requirements for the authenticator? I think like right now we commonly see some sort of like 64-bit random keys that are generated for some of these authenticators or app passwords that are then left forever, as far as, like API keys, et cetera, similar.
Right. Really the requirement for out of band is that the device, not so much the provider, but that the physical device be authenticated, and it needs to pass through a secure channel. So hopefully the provider is kind of irrelevant there. I mean, there are other sorts. There are lookup secret authenticators that I didn't really talk about, but you'll see them there in the specification that probably correspond better to your example of like a 64-bit thing that might be printed and you store in your Strongbox or something like that.
Okay, that was the last one. So thank you, Jim.
Thank you.